we first need to talk about what perfect squares are, perfect cubes, and perfect fourths. And we know the perfect squares because 1 times 1 is 1, and 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. I give you this list on the test. I'll give you all the perfect squares, cubes, and fourths. What is 6 squared?
36.
7 squared?
49.
8 squared?
64. Yeah.
9 squared is 81, and 10 squared is 100. How about after that?
121.
Good. 144.
163.
169.
Dang it.
Here's one that everybody forgets.
196.
Nice job.
Oh.
196.
Oh, I know this one.
15 squared is 225. And 16 squared is 256. So it would be good for you to be familiar with those and remember those. The more familiar you are, it's going to be easier. However, I do give them to you on the test. Perfect cubes, that would be 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 8 is a perfect cube. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 is 25. Times 5 more. 125. 6 times 6 is 36. 6 more is 216. I really don't think that people need to remember beyond the 5, but I'll write these next couple down. 7 times 7 times 7 is 343, and 8 times 8 times 8 is 512. Not going to do a lot of the fourths, but we're going to do the basic ones. 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is... So 16 is a perfect fourth. 3 times 3 is 9, times 3 is 27, and times 3 more is 81. So 81 is a perfect fourth. And I really think if you remember up to that, you're probably pretty good. But I will let you know that 4 times 4 is 16, times 4 is 64, and times 4 more is 256. So 256 is a perfect fourth. And 5 times 5 is 25, times 5 more is 125, times 5 more is 625. Okay? So our objective for the day, we're going to do these 6 problems, and we're going to let you start a little bit in your homework, and then we're going to do 6 other problems and let you finish off some of that homework. But we want to be able to simplify our radicals. And I want to be clear that I know some of you learned simplifying radicals by this. You learned to go 48, so we'll go 2 and 24. We'll go 4 and 6, and we'll go 2 and 2, and we'll go 2 and 3. That's not how I teach it, okay? So if you've got a way like that that works well for you, fine. I don't believe you're going to be taught like that in a college class. I'm going to show you what we tend to show people right now. I did ask last year's class about this. They said that they appreciated that I showed them this way. 48 can be broken up into 2 square roots, namely 2 numbers that multiply to 48. Can you think of a number up here on the board that's 8? So since I'm doing square root right now, I want to look at the perfect squares. Can you think of a number here that divides evenly into 48 that's in the red? So 48 would fall right here. Do you think 48 is divisible by 36? No. 25? No, 16?
No.
9?
Yeah.
4? All you can do is try. You can go ahead and take your calculator and say, we'll try 48 divided by 16 and see if it works. Hey, I get 3. I can take 48 and I can divide it by 9. See what I get? Nope, doesn't work. I can take 48 and I can divide it by 4. Yep, it is divisible. But I'm going to take 16 and 3. I'm going to take the biggest one. So I go here and I write 16 and I write 3. The first number is always the one you can take the square root of. So the square root of 16 is 4. And then I leave the second part alone. So it's 4 roots of 3. The next one, I've got 28. I want to look up here. Is there a perfect square that divides evenly into 28? 4 goes in how many times? So I'm going to write the square root of 4 times the square root of 7. Again, the first number is what you can take the square root of, and the square root of 4 is 2. Now I have the root of 7. Square root of 125. I look up in the perfect squares. Is there a number up here that you think divides evenly into 125? Yeah, let's try 25. If you take 125 and you divide it by 25, you actually get 5. So that works out. I take the square root of 25 and I get 5 roots of 5. What's different about these next 3? Cubed or fourth roots. So we divide it the same, cube root and cube root. The difference is, instead of choosing a perfect square, we choose a perfect cube. So if I have 16, I'm looking, what is the perfect cube that divides evenly into 16? 8. So I go 8 and 2. The cube root of 8 is 2. That's my simplified answer. Look at the next one. It's a fourth. So I'm going to find a perfect fourth and another number that multiplies to 162. So I look down this list. Perfect fourth. Is there a number that divides here evenly into 162? 81 goes in how many times? So, yep. So I put 81 and I put 2. What is the fourth root of 81? 3. So I have 3 fourth roots of 2. Then my last one, cubed root of 81. So I'm going to divide it up into cubed root and cubed root. I look at my perfect cubes. What's a number here that divides evenly into 81? 27 goes in how many times? 3. If you can't come up with those, you got to turn to your calculator. I see that the cube root of 27 is 3, and I get cube roots of 3. Take out your homework. What I would like you to do right now is look at those first 6. Please look at those first 6 problems and see if you can start simplifying those. After about 5 minutes, we're then going to move on to the second part where we start to look at some variables. Again, if you need to use your calculator, please go ahead and do so. volleyball team tonight. Okay, let's flip to the back side here. Good work. I should rewrite number 8. It should read the cube root of 27. Y cubed is e to the 6th. So the root should be, symbol should be over all those terms. And these first 3 are perfect roots. So for example, this is a perfect fourth root, meaning we don't have to separate it. Do you remember what we wrote down? Do you remember what the fourth root is of 625? What number you multiply 4 times together to get 625? It is 5. Now notice we have a variable here, okay? And I'm going to write this out, but I'll only really do it just once for you, okay? And notice we have x to the 20th. So we're wondering what do you multiply 4 times together to get x to the 20th? Watch this. X times x times x times x is x to the 4th. So that's not it. X squared times x squared times x squared times x squared times x squared. Well, that's x to the 10th. Well, I'm sorry, I'm 4 times. I'm sorry about that. Sorry. Okay, so I multiply those 4 times together, I get x to the 8th. Well, that's not it. X to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Remember, if we are multiplying, what do we do the exponents? We add them, so you get x to the 12th. So x to the 3rd is the perfect cube root, or perfect 4th root. Anybody know what the perfect 4th root would be? X to the, close. If we do x to the 4th, then we do x to the 4th, x to the 4th, and x to the 4th. That's 4 fourths, so that's x to the 16th. So it's x to the 5th, x to the 5th, x to the 5th, x to the 5th. You have 4 times 5 gives you x to the 20th. So it's an x to the 5th. That's what you multiply 4 times together to get x to the 20th. The next one, what's the cube root of 27? What number do we multiply 3 times to get 27? 3. Y cubed. What thing do you multiply together 3 times to get y cubed? Just y. And what do you multiply 3 times together to get z to the 6th? Z to the 2nd. Because again, z squared times z squared times z squared makes z to the 6th. That's the thing we multiplied 3 times together. Okay, last one before we move to the little difficult ones. Do you remember on the front what was the cube root of 216? 6. And then what do we multiply 3 times together to get x to the 15th? X to the 5th. Okay, so that's really nice if it's a perfect 4th or a perfect cube or a perfect cube. But what about number 10? That's different. Notice how it has variables in it, but this time 32 is not a perfect square. So I divide it up into 2 parts. And I start with the 32. What numbers do you multiply together to get 32? One of them has to be a perfect square. 16 and 2. Okay, when you were going to say?
8 and 4.
She's right. No, watch. Suppose that Caitlin didn't pick 16 and 2. Suppose she picked 4 and 8. That's fine. She gets 2 roots of 8. Now I ask myself, is there a perfect square divides evenly into 8? 4 and 2. So she would have 2 times the root of 4 times the root of 2. Well, the square root of 4 is 2 times 2 is 4. So you get the same result either way, right? So that just would have taken you another step. So we chose 16 and 2. Is x cubed a perfect square? It is not. So we reduce the x cubed by 1 power. We make it an x squared. Is x squared a perfect square? Yes. But now watch. I've got 16 times 2 is 32, but x squared times what is x to the 3rd? X. Y squared is a perfect squared, so it goes there. So on the right side is everything you can't take the square root of. On the left side is what you can take the square root of. And we get 4xy roots of 2x. Now I get it. Radicals throw some people's brains for a mess. I get it. That's what makes this difficult, but we need to practice this. This is one of those pieces that sometimes people don't keep up as well with when they get to a college level class. Is 49 a perfect square? Yes, it is. So I put that under the first one. We're good to go. Is x to the 5th a perfect square? No. So what do I put under there instead of x to the 5th? X to the 4th, and we'll put an x over here. Y to the 7th, I'll reduce it to y to the 6th, and I'll put a y over here. So now I take the square root, and I get 7x squared y to the 3rd. And then I have a square root with underneath it, I have just xy. Our last example for the day, I'd like you to try it on your own so we can check to see if you can do it now without the help.
Are you just reducing?
Okay. So x squared times x squared is x to the fourth. Oh, is that a 3?
Yeah.
Oh, yeah, okay, yep, you're good, yep, sorry. I thought it was a 5, my bad. Hey, Jacob. How'd you do, Jacob?
Probably bad.
Probably bad? He says probably. Should I grade it right now in front of everybody?
Sure.
Doing pretty good so far. What if I can't read his handwriting?
Give it to him.
Right here. I think it's going to.
Does this go down or this? Since it's a
Yes, so it
perfect
becomes
square.
x squared. Yep. Okay. So I'm gonna divide this up into 2 parts. 25 and 2. X to the 4th is a perfect square, so it stays there. Y cubed becomes y squared and y over here. So the square root of that should be 5 x squared y, and then I have the root of 2y. That's that. So I want to show you on your homework what you can currently work through now. You did these first 6 problems. You can finish off the front and go a little bit to the back side. The back side is 3 at the top. Tomorrow we'll be focusing on adding and subtracting radicals. And we will practice simplifying like we did today right at the beginning of class. You should get enough time to work. You should hopefully be able to go into the weekend without any work in this class to bring home.